Hello everyone, welcome to this Abaqus thermal tutorial. Today we are going to simulate a moving heat source. So without waste of any time, we're going to create the part. So the part 1, let's have it 100. It should be deformable solid extrusion. Continue. And here we are going to create a rectangle like this. And the dimensions for here, we have it 5 for this guy and we have 60 for this guy, and we click the scroll button and this one should be 30. Alright, we have the part here. I would suggest you to go to the View tab and from Toolbars click on this Views so that you can rotate easier, and by this one rotate, we are going to rotate on this part and we click on partition face sketch, we select this one and scroll button vertical right, and we have this guy here, scroll button again, then we have a part like this and we want to extrude that, so left click and hold on this one, so we choose this one and we want to sweep along the edge, and we use this edge, create partition, so that we have the partition like this. Alright, the part creation is over, so let's go to the properties. Here for the properties I use the material named steel, and from general density we check this one, use temperature dependent data, and we have the temperature dependent data here, Control C, Control V, and from the thermal we need conductivity. Again, I use temperature dependent. This is conductivity, and from the thermal specific heat, we are going to have a specific heat here. Again, use temperature dependent data, and there we go. Alright, create section 1, solid homogeneous, and the material is steel. Now we assign the section and the section is assigned. Okay, property is over. Let's go to the assembly. Here we assemble our part. The mesh can be independent. Now we have to create some parts here, so I choose the define cutting plane. So this cell, 3 points, this one, and this one. We have 2 parts here. Now we should have more parts. I'm going to divide this one into 2. Three points. It's a little time consuming, but it's the best way to create these parts. There we go. We have 1, 2, 3, 4, 5, 6, 7, and 8 parts. So the heat source would go from this part to this part to this part and till the end. So let's go to the step. Here from create step, I would like to use the heat transfer. The time period for each one should be 1.5. So this is 1.5, and we have 8 of them. So we want to create 8 steps. So this one should be 1e minus 5, 1e minus 3, and this one should be, let's say, 1, and the maximum allowable temperature should be 300. So step 1 is created. We're going to do the same for other steps, so I'm going to pause the video in order to save the time. Okay, I created 8 steps. Just made a mistake. This one should be 1e minus 3. So we create 8 steps, and they are all the same. This one should be 1e minus 3 as well. Okay, yeah, everything should be like this. So this is the step is done. Now we can go to the interaction. So from this one, create interaction property, we're going to select film condition, and we use temperature dependent data. We use the film coefficient, Control C and Control V here. Okay, now we are going to create the interaction. So from here, and from the step 1, we create the interaction of surface film condition, and we select everything, and we rotate the instance and escape. Now by holding on Control, we are going to remove this bottom part. So it should be everywhere except the bottom part. So done. And here, instead of embedded coefficient, we use property reference, and we have this property here, and the sink temperature should be 30 centigrade. As you see, the interaction is created, but on the bottom part we don't have any interactions. So the interactions are finished. Now we can go to the load. From here, create a load. I'm going to create a load on body heat flux, and in the first one, so it should be 2.5 watt over millimeter cubic. So this is 2.5. It's created, and as you see here, the loads are there. I'm going to deactivate that for the step 2, and I'm going to create another load for the step 2, and it should be on this guy. It's 2.5 again, and it should be deactive for the step 3. Load 3, step 3. Okay, here, and the magnitude should be the same, 2.5. Deactive here. I'm going to do that for the 8th of them, so I click on pause and come back. Okay, the loads are created. So let's see here. We should have loads like this created and inactive for the next step. So you can also double check that the loads are correct. So here we have load 1, load 2, load 3, 4, 5, 6, 7, and 8. So everything looks good. So let's create the initial temperature by clicking on predefined field, and here the initial, others, and we can use the temperature. We can use all of the material, and let's say 30, which is the initial temperature, and click OK. So the load is done. We come back to the step to create another step. We call it cooling. It should be heat transfer and should be after step 8. The time, let's say 5000, and we can have 1A minus 3 for this one, 1A minus 5 for this guy, and something like 500 here and 300 for this one. So as the step was done, we go to the load once more and deactivate this one. So it's better to create all the steps at once than apply the load. So interaction was done, load was done. It's time to go to the meshing. From here I click on cells and select all these cells, and I click on seed edge by number and 4. Okay, now I can mesh my part and see here I have the mesh. I also can create bias on the sides. So let's delete the mesh and we can see the edges here and here. So these two and that two. Let's say single bias, and the number of them, it can be like 8, and we can mesh it, and as we see here we have a bias and the elements are smaller here. So the mesh is finished. Before creating the job, we have to make sure that the mesh, from here assign element type, we have to make sure that the mesh is on heat transfer and this convection and diffusion is clicked. Now let's create the job and run it. So we create a job, moving, heat, source, temperature. So we accept everything, click on submit, yes, and monitor. So I pause the video and come back after the job is completed. So as the job is completed, we can go and see the results. This is the final results. Instead of the heat flux, we would like to see the nodal temperature. So let's see how it goes from the beginning. Okay, so let me bring it back here. It starts like this, and as we go further, we see that the heat source is moving, and it goes to here, the final steps, and it reaches to the temperature of 46. Okay, that's it. I hope you enjoyed. If you enjoyed this video, please like it, and if you want to see similar content, so please subscribe to this channel. See you in next video.